Geometric sequence in series, multiplying previous term by a constant. A series, again, is when you're adding them all up. A sequence is just a list of numbers. And multiplying the previous term by a constant. The way it's defined is a sub n equals a sub n minus 1 times r, which means you take the previous term and you multiply by r, and r is called the common ratio. Okay? And you could also, to find r, all you'd have to do is take a sub n and divide it by the previous term, and that would give you r, right? Algebraically, that's the way you would do it. Okay? Now, to have an actual formula for finding the nth term, very similar to what they do for arithmetic sequences. If a sub 1 is equal to a sub 1, and a sub 2 would be equal to a sub 1 times r, right? You get that? And a sub 3 would be a sub 1 times r what? Squared, right? Because you're multiplying by r again, and so on. So a sub 4 would be a equal to a sub 1 times what? R cubed, right? So if you want a formula for finding the nth term, a sub n is just equal to a sub 1 times r raised to the n minus 1. So if you're trying to find the sixth term, you know the first term, you plug in 6 in here, and you have to know r and you have to know a sub 1, but if you want that nth term, that's the way you would find it, okay? For instance, find the 20th term. Find the, well, let's first do, that's okay. Let's find the 20th term of this sequence. 1, 3, 9, 27. So you guys could probably figure that out pretty easily, right? But what's a sub 1? 1. A sub 1 equals 1. What's r in this case? What am I multiplying the previous term by to get the next term? 3, right? Okay? And so that's 3. So if I want a sub 20, and if it's not easy to figure out, like if you have a fraction or something like that, just divide. I'll show you another one. So a sub n, in this case, is going to be equal to 1 times 3 raised to the n minus 1. So if I want the 20th term, I don't really need the 1 in this case because, you know, it's 1. But if it were something other than 1, then you'd need it there. But in this case, I don't really need the 1. So this is equal to 1 times 3 raised to the 19th power. And if I do that on my calculator, I just get 3 to the 19th power, which is a big number. 1 billion. 261,000 and 467. So you can see with geometric sequences, things go up very, very, very fast, you know, because you're multiplying by a number each time. Okay? We're good? Yes? Okay. If you do have something like this, just to give you an example, find r. If they say find r, and you have something like this, starts at 1/2, then it goes 1/4, then it goes 1/8, then it goes 1/16, dot, 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 dot. what am I multiplying by each time? 1/2, right? And if you couldn't readily figure that out, you know, in your head, you take this term and you divide it by this term. So 1/4 divided by 1/2, right? Do you know that copy dot? Yeah, so you copy dot flip, okay, and you get 2/4, which is 1/2, right? So if you see something with fractions, you just, or anything that looks pretty complicated, you just divide the preceding term into the next term, okay? So then the next thing you're going to see, and that's a lot like the one we did before with an arithmetic sequence, find the 15th term. Of a geometric sequence. With a sub 3 equals 5/4 and a sub 6 equals 5/32. Okay, so this one's a little tricky because it has fractions, and it's kind of like the last one, like that one I did up on the board up there, where you were given two terms and you had to come up with the equation. So that's what we're going to try to do. So we know that it's using the formula a sub n is equal to a sub 1 times r to the n minus 1, right? Using that formula, I can come up with, for the third term, I can come up with 5/4 is equal to a sub 1 times r, which I don't know, raised to the what power?
Squared.
If it's a third power, right? N minus 1 would be 2, right? And then I have another equation that says 5/32 is equal to a sub 1 r to the what? 5th, like that. So how would I solve that? So what I need to do is solve that for a or r, okay? How would I do that? Yeah, substitution, I would just, what I did, I don't know if this makes sense to you, I just divided this equation, okay, by this equation, okay? 5/4 equals a sub 1 r squared. Can I do that? I can do that. What would happen to the a's if I did that? That goes away, right? And then I have r to the what? Third equals 5/32 divided by 5/1, which I copy dot flip 5/32 times 4/5, right? The 5's go away and I get what? What is that? 1/8. And so if r cubed is 1/8, then r is, what's a cube root of 1/8? 1/2, okay? So that's kind of a tricky one. And then I have to go and find a. Well, I could plug into either of my two equations. This would probably be the easier one to plug that into. So I get 5/4 equals a sub 1 times 1/2 squared, right? So I get 5/4 equals a sub 1 times 1/4. So what's a got to be? A sub 1 equals 5, right? Because 5 times 1/4, just do the math, right? Cross multiply and get a sub. So now your equation, so this is kind of a long problem. A sub n is equal to 5 times 1/2 raised to the n minus 1 power. And if I want the 15th term in there, I plug in 15 in there, I plug in 15 in there, and I would get 5 times 1/2 raised to the 14th power. And if I do that on my calculator, I get 5 over some big number. And that big number happens to be 16,384. Get it? Let's pause if you want to write that down. So the sum of a geometric sequence, S sum of a geometric. Do you just want the formula, or do you want me to tell you where it comes from?
Just the formula.
Who wants to know where it comes from? Oh, Marion. No, Indian. All right.
I'm kidding. I don't want to know.
You don't want to know?
I'll look in the book tonight.
You can look in the book and figure it out. But it turns out that S sub n, okay, if I were truly ambitious, it's really not that bad. They use a process called, maybe I should go through it with you.
Yeah.
I think it's worthwhile. It's kind of fun. Okay, so if you, this one, you don't have to write this down. I just want to show you where it comes from. So you have, so S sub n is equal to a sub 1 plus a sub 2 plus a sub 3, okay, plus dot 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 until I get to, whoops, a, that's wrong, okay, a sub 1 plus a sub 2, so a sub 1 plus a sub 1 times r, right, plus a sub 1 times r squared, plus dot 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 a sub 1 until you get to r to the n minus 1 power, right? Okay, if I were to sum up that sequence. Now, what they do, they multiply both sides by r, okay? So if I multiply both sides by r, I get r times S then is equal to, what would this be? A sub 1 r, right? Plus a sub 1 r squared plus a sub 1 r cubed, dot 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 dot. But I'd end where? R to the n, right? Now what they do is they subtract, okay, this minus this. If I subtract this minus this, I get, so S sub n minus r times S sub n is equal to a sub 1, because there's no a sub 1 over here, right? But there is, but all these will cancel, right? Indefinitely until I get to this one, and until I get to this will cancel out until I get to a sub 1. That's right. Until minus a sub 1 r to the n. See? So everything will cancel, and this will even cancel with the term right before this. But this has nothing to cancel with, right? So you'd have minus a sub r1. And then you have this formula. And then what they do is they factor out an s sub n from here. S sub n, and that's 1 minus r equals a sub 1 minus a sub 1 r to the n. And then they divide both sides by 1 minus r, and you end up with the sum is equal to a sub 1. I'm going to factor out an a sub 1 from the top, 1 minus r to the n over 1 minus r. And this is the formula for the sum of a geometric sequence, which would be a geometric series. Okay, so as far as, do you need to know how that, where that derivation comes from? No, but it's kind of interesting to know that it comes from somewhere, you know.
Keep writing it wrong.
So what that says, if you want the sum of a geometric sequence, you take the first term, 1 minus r raised to that, and then divide by 1 minus r. So for instance, to use that in a problem, they would say, I better copy this and put it on a new page. Oh, I'm on a blank page. That's okay. So, so they say, evaluate, let's see how well I can write without blanks. Evaluate the sum from n equals 1 to 20 of 2 times 0.1 raised to the n. Okay? So that's a geometric sequence because you're taking, starting at 2, and then you're multiplying by 0.1 and raising it to a power. So what's a sub 1 in this case? It would be 0.2, right? Because if I plug in 1 in here, right, I get out 0.1 raised to the 1, which is 0.1 times 2 gives you 0.2. So the sum using this formula, I'd have 0.2 times 1 minus, what's r? What am I multiplying by each time? Right here. 0.1, okay? 0.1 raised to the 20th power, okay? Because you're, whoops, I messed up. It's in the parentheses. 0.1 raised to the 20th power. That has to be in parentheses like that. Over 1 minus 0.1. Okay? So on the top you have 0.2 times 1 minus 0.1 raised to the 20th power, which is a number very, very close to 1, isn't it? 0.1 raised to, no, it's a number very close to 0.2. Okay? And over down the bottom you have 0.9. And so if you do that, you end up, if you do that on your calculator, I guess this is almost 0, right? Isn't this almost 0? Right? 0.1 to the 20th power is 0.00000000000, right? Yeah? Understand that? So what you end up getting is a fraction very, very close to 0.2 over 0.9, which is 2 ninths. Okay? Yeah? Essentially, that's what you get. Okay?
Yeah, it's exactly 1.
It's exactly,
Time, yeah, 1 times 0.2 over. So it is exactly 2 minutes.
it is exactly, well, it's not exactly. Yeah, your calculator just runs out of mean.
Rounding up.
Yeah. Okay.
That's enough.
Okay. So then for the sum, so the sum of an infinite geometric sequence, let's move on. Let me grab this thing again. Now it's giving me, I don't like that kind of paper. I like the other kind of paper. File, edit, copy. File, edit. Okay. So the other formula is for the sum of an infinite geometric sequence, which is kind of cool. Geometric sequence, also known as a infinite series, okay? AKA, I should say AKA. Also known as an infinite series, because you're adding them all up forever. Infinite series is given by the formula. So think about it. It's kind of like in the last problem. If r is, absolute value of r is less than 1. That's it. It doesn't say rk. That's kind of, if the absolute value of r is less than 1, meaning you're multiplying by a number less than 1 each time, as this n number gets very, 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 very big, right? What's a fraction raised to a huge power?
Really small.
Really small. It goes, so this essentially disappears. See that? As this number gets very, very, very big, this number gets very small. And what you end up with is S sub n, you can put a little infinity down here, of an infinite series when r is less than 1. Okay? The absolute value of r is less than 1 is equal to just a sub 1 over 1, oops, over 1 minus r. Because this thing goes away, right? If this is 1/2 times 1/2 times 1/2 times 1/2, gives you a very teeny number, right? So as you sum them up, this thing disappears, and you get 1 times a, which is just a sub 1, over 1 minus r. So if you want, girls, so say you want to evaluate Marion. And I send this video home to your parents with me saying your name in the middle of the video. Giggling. N equals 1 to infinity of 2 times, that's an infinity sign. You can't tell that's an infinity sign?
Looks like a fish.
Looks like a fish. Oh, I have it. Oh, that's more of a calculus thing. That's just not a very good infinity. Okay, 0.4 raised to the n minus 1. Okay, so in this case, if I want to, so this is saying I start with 2, right? And so if I want to add up all the numbers, 2 times 0.4 would give you, what would that be? 0.8, is that right? 0.8. And then if I, so what this is saying, if I want to add 2 plus 0.8, then what would I add? What would be next in this series? 0.8 times 0.4, what do you get? 0.32, right? Plus dot, 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 until you get to the very last term. You want to know what that adds up to, right? And so all I have to do is plug into this formula. What's a sub 1?
2.
2 over 1 minus 0.4, which is 2 over 0.6, right? Which is equal to, I want to get rid of that decimal, so I'm going to multiply by 10. 20 over 6, which is equal to 10 thirds. See? So if I add all these up forever and infinity, my sum would be 10 thirds. How do you like that? Isn't that cool?
So cool.
So it gives you the sum of adding up numbers from 0 to infinity, or 1 to infinity. So this has an application or two. Here's a good application. Say that you dropped a basketball, okay? This I don't know if this one's in your book. I steal these out of the teacher. You drop a basketball. From 10 feet. Okay. It bounces. It bounces with a, they call it rebound ratio or something like that. Rebound ratio of 65%. How far will the ball travel? Okay? In its total trip. Okay? So basically what's happening, here you are at 10 feet. What's that? Is that how high a basketball hoop is? 10 feet? Yeah. So the basketball goes down 10 feet, right? And then, so this is 10, and then it's going to bounce up how far? 6.5 feet because it's got a rebound ratio, right? And I'm just showing you kind of, and then it's going to fall down how far? 6.5, right? And then it's going to bounce up to 65% of that, right? Whatever that is, and then it's going to bounce down, and then it's going to keep going and keep going and keep going. And you say, well, the ball will just keep bouncing forever, right? But it turns out that it actually approaches some infinite distance that it travels. Now this one's kind of tricky because it only goes at, if you drop it from 10 feet, it only drops at 10 feet once, right? Okay, so the way you would figure this out, you would have to add the 10 feet at the beginning, okay? Plus, how many times does it go 6.5 feet? Twice. So you have to take 2 times the infinite sum from n equals 1 to infinity, okay, of 10 times 0.65 raised to the n. Understand that? Okay? Because on the first bounce, so if I plug in 1 in here, I'm going to get 6.5, but it's doing that 2 times, right? It's going up once and then down once. And it's going up and it's going down, up and down, up and down. So if I do that out, okay, so I get 10 plus 2 times the infinite sum, which is just a sub 1. What's a sub 1? It's not 10. What's a sub 1? We already counted for that 10 feet it fell at first, right? 6.5 over 1 minus r. What's r? 0.65. 0.65. And so I get 10 plus 2 times 6.5 over 0.35. And it comes out to be a very finite distance that ball will travel, which happens to be 47.14 feet. So you can't say it bounces forever. It reaches a limit, okay? Which is kind of weird, you know, to think about, right? You would think it would just keep bouncing forever and ever and ever, but it's just adding smaller and smaller and smaller and smaller pieces until you approach some limit. It's 47.1. How about that? Here's a good question for you. Did I ask you this question? If your parents said, we'll pay you a penny a day. Did I ask you this problem before? I think I asked you in geometry. And they said, I'll pay you a penny a day. All you have to do is every single thing I ask you. Clean up your room, do all the chores, I don't know, do all your homework, get an A on every test you take for the month. I don't know, whatever your parents want you to do. To do everything for an entire 31-day month. All you have to do is, and I'll double your salary every single day. So on the first day you get 1 cent, second day you get 2 cents, third day you get 3 cents, or 4 cents, okay? Fourth day you get 8 cents. Would you take that deal? Well, how would I figure out how much money you would have after that? Okay, so it would be an infinite sum of it wouldn't be an infinite, right? It would be the sum from n equals 1 to n equals 31, right? Of your first term, which is 1, times r, which is what? 2, right? Raised to the n minus 1. You understand that? Okay? So if I do that sum using the formula, what's a sub 1? A sub 1 is 1 minus a sub 31 would be 1 minus 2 raised to the 30th power, right? Over 1 minus r, which is what? 2. Okay? So if I take 2 to the 30th power, subtract 1, or subtract 2 to the 30th power from 1, so it's actually 1 less then 2 to the 30th power, right? Because if I'm dividing by -1, that sign. So 2 to the 30th power, do you have a calculator? What's 2 to the 30th power? See if you give me an answer.
A lot of numbers.
What did, read them to me.
1, 0.
No, I thought it's 1 times 2. Yeah, okay, go ahead.
0, 7, 3, 7, 4, 1, 8, 2,
1, 8, 2, 4. Oh, I put the comma in the wrong place. Okay? So that's how many pennies you'd have. So you have to move the decimal place. That's how many dollars you'd have in sum after 31 days. Okay? You would have $10 million, $10,737,400. $10,737,418. That's pretty good. Starting out to penny day. So tell your parents to do that, and you'll do anything they want. And then give me half of it. Okay, that's the end. Your homework is online. It's a lot, but you have a lot of time. You have almost 50 minutes. Okay, so you can blame Mr. Beamer for this assignment.
Oh my gosh.
It's not that bad. You could get it done if you want. So if you want to do the Colorado Math League, what time do we get out? At 58 or so. I have that, and you can have anyone you want to start on your homework, and then if you want to do it, want you to start on your homework, and then at like 10 after, I'll give you the Colorado Math. Okay. Is it a deal? Okay. And you can borrow books and something like that. I think I did that properly. 1 minus this one's r to the n. Would be r to the n or r to the n minus 1? R to the n. So that should be the 31st power. It would actually be the 31st power. So it actually comes out to be 200 and something million, 20 million and something. So I think I screwed that up. I was just trying to make that one up. Okay, what's this? Homework here. Why don't you go to the bathroom real quick? So work on that for a while, and then I have lots of Colorado Math Leagues. That's
Stop recording.
Stop recording. I'm still talking? Oh.